Hi there, this is session 10 of programming from the very basics using Python. So in this session, we will learn all about assignments in Python. We did learn very basics about how do you create a variable by using assignments, but we'll go a little more deeper in this video in showing it where I'll show you all the different forms of assignments officially supported in Python code. So first of all, we have learned the simple assignment so far in my earlier videos, where you can always create a variable by using a is equal to, and you can pass any expression like say 3 plus 4. And when you try to print a, the result of that expression is printed. So you can see that this kind of an assignment is called a simple assignment because there's just one expression in the right hand side and there's one variable on the left hand side in this assignment. So we simply call this as a simple assignment in this case. But Python does support some other forms of assignment. Another form that you would have already encountered in one of my earlier sessions when I introduced you to tuple is tuple packing. What does it mean? I could actually use something like a is equal to, I could say 2, 3, or 2, 4, whatever number. And I can also use some expression, 5 plus 6, any expression will do. I can also use it very arbitrary, like I could use a string, for example, test. So when you have comma separated expressions or values, right, literal values or comma separated expressions in the right hand side of an assignment, and in the left hand side, if you just have one single variable, by default, Python packs the entire outcome in here into a tuple, and then a refers to a tuple. I think I gave you that example where I just showed you an example where I have two pencils and I have one single label. So if at all I want to use one label to label two pencils or multiple items, the better idea is to put those items in a box, that collection we call them, or a container, right? And label the container. And that's exactly what Python does. It creates a new tuple object, and then the tuple object will represent all these other elements on the right hand side. And therefore, when you try to print a and type of a, this is what creates a tuple, right? There are certain things you should know about tuple construction in this case. It's a little bit of, it's like trivia. If I say a is equal to 10, if I type a is equal to 10 and print a and type of a, you might see that it's an integer. But if I try to use something like a is equal to 10 comma 20, and you can see that the type of a is a tuple. When I mean type of a, whatever object that a refers to, that's a tuple. I guess you know that variables don't have types. I keep re-emphasizing that. It's the objects that have types. Variables are merely labels, right? They're just like sticker labels stuck on these objects. Now, having said this, what if I want to create a tuple of just one element? Now, you will ask me, is there any use case for it? Well, when there's more than one element, it makes sense to box them in a collection. But when you just have one item, you might ask me, why do you want to create a tuple? There are certain expressions in Python that expects an argument to be some kind of a collection. There may be expressions that you'll encounter in future where the argument must be a collection. But how do you tell that expression that I just have just one item? I just have one item. You can't just pass an item when a collection is expected. It'll throw an error because maybe it'll try to iterate over it. You cannot iterate over non-collection entities. So this is a use case. So how do you create a tuple out of just one item? Well, the way you do that in Python is a little weird. These are some of these syntaxes, which not many people would find it intuitive, but this is how we do it. You just say a is equal to 10 and just end with a comma. Just know this. When I type a is equal to 10, no commas at the end, you get an integer. But if you end with a comma, what really means is that create a tuple with one item and nothing else. The comma is like, and what else? Nothing else. So it just creates a container with just one item in this case, and That's how you can get a single element tuple, right? By using the syntax. Of course, some of them might say, should you not put parentheses here? As I told you, a parenthesis is not really required as long as there is no syntax ambiguity in Python. So in this case, whether use parenthesis or not use parenthesis, they'll all just work fine. You can just try it out. They both will give you a tuple. So this is how you create a tuple of one item. If you want to create a tuple of no elements, you want to create an empty tuple. The way you do that is by using a is equal to open close parenthesis as is empty parenthesis creates an empty tuple. Maybe you have an expression in Python that expects some kind of a collection as one of its argument, but then you want to say there's nothing. One of the ways you do that is by passing an empty tuple as the argument, and that is what works here, right? So this is how we can create an empty tuple. This tuple has no items, and I guess in the Boolean context, this will be evaluated as false. I think I talked about it when I talked about Boolean expressions, right? So this is an empty collection. Empty collection is evaluated as false in the Boolean context. All right. When I mean Boolean context, that means any expressions where Boolean expression is expected, any statements or any constructs that expects a Boolean expression, you pass an empty tuple, he'll assume it's false rather than true and work accordingly. If else conditions, for example. Now, this is tuple packing, and I told you how you can automatically pack tuples by just using comma separated items, including single element tuple in this case. If at all I want to, let's say, create I have a tuple already. Let's assume I have a tuple. I'll just type a is equal to 10, 20, 30 for now. A 3-element tuple. Okay, so if we just type print a and type of a, it shows it's a tuple. I know that a is a tuple now. A represents tuple. I want to unpack it. If at all I want to unpack a tuple, I can do that by using a technique called tuple unpacking. All you need to do is just have comma separated identifiers on the left hand side. In this case, 3 variables, b, c, and d equals a. And now if you just check the value of b, the value of c, and value of d, they'll be independently shown up. The value of b is printed as 10, the value of c is printed as 20, and value of d is printed as 30, as you can see here. Now, this is how you unpack a tuple. And there is one important thing you should note. If at all you're unpacking a tuple, the number of variables on the left-hand side must exactly match the length of the iterable on the right-hand side. I carefully used a word here, iterable. You'll very soon realize why. The right-hand side can be any iterable object as long as it can provide exactly that many items as many variables exist. This tuple unpacking would work. But if at all you have a scenario where I'm just going to use a from the previous cell. The previous cell, a is just there with that 10 with that 3-element tuple, right? If I just try b comma c is equal to a, you'll get a value error because this is a syntax ambiguity. What it means is that a refers to a tuple that has 3 items, and you ask it to be unpacked, and you got just 2 items here. You just have variables to represent 2 items. What about the third item? Python will just not ignore that. If there's nobody to refer to the third item, Python will throw an error. This is a runtime error. It shows a value error that you see here. So in execution, it shows that it could not really unpack this tuple because the tuples had too many values. What is expected was just 2 values. Now, some of you who might want to ask, oh, I have a tuple that's of different sizes. It could have 10 members, 6 members, 4 members. It could have any size. But I know it's definitely greater than 2. I know the minimum number is 2, but the size can vary beyond 2. It can be 3-element tuple, 6-element tuple, 100-element tuple. But I just want to get the first 2 items alone into 2 different variables. How do I do that? Well, Python always has a lot of tricks under its belt. So if you can try this out, you can see b comma c is equal to a colon square bracket. Okay. And this time I'm going to use something called slicing. I'll talk about slicing and sequences in great depth. And I talk about sequence collections specifically. But for now, just note this. When I say A of 1, it's going to check one item from a collection. Tuples, list, all sequences. Checks one item from that particular sequence collection. But if I want to get the first two items from this collection, because there are only two variables, I need just two items, I can just try colon 2 here. This will work. Or just try B and C. Will show you 10 and 20. Here's it. So it doesn't matter how many items A has. It can have more than two items. If there's less than two, there's a problem. That is something you should know about, right? It expects at least two items to be there in the tuple represented by A, but it could have more than two items, but I'm interested in only the first two elements of it. This is a trick that you'd use. But you can see that it takes 10 and 20. You might ask me, what if I want last two items? I don't want 10 and 20. Maybe let's assume that A has got more number of elements now. A's got 10, 20, 30, 40, 50, 60. There are 6 items in A. If I try to use B comma C is equal to A of colon 2 and try to print B and C, it extracts the first two items from here. Colon 2 is like first two elements up to second index, up to, not inclusive. 0, 1 is taken in. That's how you read it, okay? The first two elements. But what if I want these two elements? The last two, that is. What do you think would be the trick to do it? Well, you might wonder, I need to find out the length of this particular collection, and then you have to use some kind of jugglery with, length minus something, right? No, you don't have to struggle that hard. All you could remember is minus 2 colon. Sorry, something under my leg. Sorry about that. Minus 2 colon. What I mean to say here is that the last two items are selected. What is minus 2? This is index minus 1. In a sequence collection, this is 0th index, first index, second index, third index, this third, okay? This third index, this fourth index, and this fifth index. So it goes as 0 to 5. That's how indices are represented. So if you want to use a subscript operator, that square bracket in this case is called as a slice or subscript operator. Okay, that's the name, official name given it. So if you're going to use a subscript operator to get a item of a collection, you can use indices which are positive. Positive indices will start counting from the beginning, starting from 0 all the way from left to right. But if you use a negative index, it starts counting it as this is minus 1. The last item is minus 1. This is minus 2. This is minus 3, minus 4, minus 5, and minus 6. That's how you read it. So if you want to get the last two items, this is minus 1, this is minus 2. This will select these two last two items. I say minus 2 colon. This colon is also very important. If you don't use a colon, it will throw an error. Even here, if you don't put a colon 2 and you just type 2 here, this won't work because there's written just one item. A of 2 will get only the second index, element is second index, but you have two variables on the left hand side, so it's going to fail. But if you really want to get a slice of a sequence, you have some kind of a colon surrounding it, right? You write indicate a start index, stop index, and colon surrounding it. In this case, a colon 2 means start from 0th index. This means start from 0th index. It's like telling 0 colon 2 is all the same. The 0 is redundant. You don't have to specify that. Instead of typing 0 colon 2, you say colon 2. That means start from the 0th index up to the second index, not inclusive, up to. Start index is inclusive, stop index is not. It's exclusive, right? So it says 0 to 2, it starts with 0, 1. 2 is not included. That's how we read it. So it's like up to 2. The first two elements, 0 and 1. That's what is returned when you run this, and this works. Similarly, if you're trying to look at minus 2 here, minus 2 onwards till the end, the till the end is represented as nothing. Or you might want to put minus 1 here. When you put minus 1 is not included. Stop index is non-inclusive. Last item is ignored if you use a minus 1, by the way. So you just leave it as colon like this. So when you say that, it's going to start from minus 2 till the end. So it's going to select the last two items. And this pretty much works. I mean, these are practical use cases, in certain scenarios where you have a collection, you want to get the last two elements of collection, first two elements of collection, and so on, you can use a slicing operation. This works for all sequence collection. I'm talking about list, tuple, strings. These three are sequences. It doesn't work for a set. Sorry, it doesn't work for a dictionary, right? When you're going to use slicing here. Anyways, so next thing I should talk about is I talked about the ways you can unpack a tuple. This is called tuple unpacking, and tricks about tuple unpacking. Sometimes you might ask, what if I have multiple variables here, p comma c comma d, e is equal to, let's say, let me make it simple. I'll say a is equal to 10 comma 20. It's a tuple, right? So you have 10 comma 20. So a is representing a two element tuple. Now if you try to do b comma c is equal to a, no problem. You can unpack this without an issue. I told you that if you also try to say b comma c comma d, then there's a problem, because the left hand side there were three variables, three identifiers, but the right hand side expression returned a tuple, or rather an iterable that gave you only two items. In this case, a tuple that just had two items. So when that happens, you get this error. It shows value error, not enough values to unpack. Expected three, because there are three variables, it's expecting three values, but it just got two. Python flags this off also as a runtime error. Oh, there's no solution for this. So if at all you want to, let's say, make it work, there's no obvious way to make it work, because you have just 10 and 20. So that can satisfy requirement for B and C. What will D store? Maybe you want to say that, oh, D can have some default value like none or zero or something else like that. Is there a way to do that? I'm just thinking. Well, yeah, maybe one quick hack would be plus 0. Anyway, it looks clumsy in my opinion. Let me know if there's a better way to do it, but yeah, this works. Placeholder. It looks clumsy because it's pretty obvious. Well, look at it. I don't think there's any practical use for it. It's just for kicks. I just try to make it work, but practically this is pointless, because the fact that you decided to have three variables, right? Assume that A should return three elements. But if you know that A only returned two elements, and you're just going to add this here, this is pretty pointless. You should rather just remove this D here and, just keep it as simple. So I told you there's no practical solution for this. Just if you want to make it work, you just add some placeholder there, and it's not really a solution. Just try it. Okay. So this is what you should know. So this is called tuple unpacking, and you should know the rules of tuple unpacking. Tuple unpacking rules expects that the number of elements in the left hand side, number of variables in the left hand side separated by comma must match the number of items from an iterable. I'm using the word iterable all the time for now, sometime now, right? I didn't say tuple, though I said it's tuple unpacking. The fact is that when you're using unpacking operations, the right hand side need not have to be a tuple. It can be any iterable object. Let me give you an example for that. It'll work with a string. Let's try this. I'll try maybe A is equal to, maybe I'll just type maybe THIS, this. A is equal to this, and I could try to say B comma C comma D comma E. Yeah, it's equal to print B, C, D, and E. Strings got unpacked because string is also an iterable object. It means you can iterate over it one item at a time. So again, get T, then H, then I, then S when you iterate over it. So when I talk about for loop, you'll understand this in great depth about the iterative protocol. But for now, it's just suffice to tell you that almost all the collections can be used here, as long as you know the length. It's very important, right? So you should know how many elements are there in this collection, and you should have exactly that many variables in here. That's called tuple unpacking. The realistic use case for tuple unpacking is, let's assume you have some kind of a record that represents some data set like this, like say John, comma, maybe 45, comma, let's say Delhi. So it's like a tuple that's got three items. So I just did not separate with space here. It's a good idea to separate with space, though it's not really mandatory. You can see that's a tuple, right? Sometimes you get a record from when you run some queries and you get a record as a tuple or a list. It's possible. It could be a list or a tuple. But you know the number of elements are fixed. It's like three items. Even when you parse some CSV documents, sometimes the parsers will return a record as a list, let's say, with three items. You know what these three items are. The first one is name, maybe the second one is age, and the last item is location. You could actually unpack them like this. You could say name, age, location equals reg. And you could print name, age, and location. And you know they're all unpacked into individual variables in here. So you can just see that the name, age, and location is all unpacked based on the items of record. In fact, instead of rec, it could be an actual function or a method that returns a collection, a tuple or a list of a known length or known size. If you know the length of it, you can unpack them to individual variables. It's a convenient feature in Python. Combining tuple packing and tuple unpacking, there's another kind of assignment that is supported in Python, the third form. I talked about simple assignment, tuple packing, tuple unpacking. So it's the fourth form. Sorry. The fourth assignment I should talk about is parallel assignment. You could do this. A comma B is equal to 10 comma 20. Wow. Right hand side is anyway a tuple. Left hand side is getting unpacked. In one end you're packing things, another end you're unpacking it. So which means that this is a shorthand scenario, sorry, shorthand way of assigning two variables. So if you have a Python code where you end up doing this, A is equal to 10, B is equal to 20, name is equal to John, you're making multiple assignment statements. That way, you can combine them in a single assignment using parallel assignment. Will it benefit any performance? Maybe yes, because every line that is interpreted is going to add more overhead in terms of performance. Lesser lines to interpret might make your code run faster. Python being a compiled interpreted language, these are things you keep in mind. And yes, a digression again is that most people say that Python is slow, slow everywhere. On the internet, one of the biggest common complaints that people have against Python is they claim it's slow. Towards the end, you'll realize that it's not that slow after all. And most people who claim it's slow are either ill informed or they are just making it up, right? Their own biases. So I used to think that Python is actually slow. Yes, an interpreted language will be slow, but Python has a lot of optimizations available and expects programmers to leverage them. Sometimes you write a clumsy code in Python, the unPythonic code, and then complain that your code is running slow. The moment you try to make your code more Pythonic, that's where your code gets more efficient. So more than, I would say 30% of your code efficiency, 30% is just a arbitrary number I just invented. Sorry. Okay. I'm just giving it my own opinion again. So I'd say like if I say 30%, some fraction of Python's performance can be improvised just by following proper Pythonic coding conventions, like things like use parallel assignments and all these Python specific features judiciously. They're good for optimizing your code. And the rest is most to do with choosing the right runtime and also choosing the right libraries. And that should go a long way to make your code run fast. So you will see me doing some videos on drag racing very shortly, where I'll try to compare all these new age so-called high-performant languages competing with Python, Rust, Golang, Zig, Nim, all these languages. And I'll try to compare them with Python and show you where they are fast and where they are slow. You'll see that. Oh no, there's no such one single language that's super fast or something. There are use cases. And yes, most people will argue and say Python is slow, but let me tell you, it's just a myth. By using the right libraries, using the proper coding conventions and choosing the right tool chains, you can make a good old Python programs, whatever you write, to be as performant or sometimes even better than C. Yeah, I will not swallow my words. Sometimes even better than C. I've seen it. Okay, so I will talk about that when I demonstrate in a couple of other videos, right? Anyway, that's a digression. I'll come back to the topic. So this is a Python specific feature, parallel assignment. It's a very interesting one, and I'll tell you one of the interesting jokes about it. Is like, one of these commonly asked interview questions in India. You know that. How do you swap two variables without using the third one? Here are two variables. A is 10, B is 20. You want to swap them. How do you swap it? The traditional programming approach is you need a third variable, right? Suppose you have A is 10 and B is 20, and you want to swap it. I've got this funny example. Swap A and B. A must become 20 and B must become 10. In all the traditional programming, what you normally do is that you need a third variable. You say C is equal to A, then C represents what the value of A is. A is now going to refer to what B is referring, and now B is going to refer to what is C referring. And then you try to print A and B, you can see that the values seem to have swapped. But you know what you can do in Python? You don't need to do this. Rather, I'm just going to put a comment here. This jugglery is not needed in Python. Juggling is not needed in Python. In Python, it can be done as simply as, if let's say A comma B is equal to B comma A, Pythonic swap of two variables. Print A and B. You can see now already A and B was swapped by the old school technique. I'm swapping them back one more time. I get back the original values, right? You can see this. A becomes B, B becomes A, and no third variable is required. Interesting. Actually, I found this very interesting when I start using them and applying this kind of logic in certain small lead code like problems. You will see those examples in the long run when I finish with flow control constructs, right, in the next couple of sessions. So there's something you should know about parallel assignment. So simple assignment, I talked about tuple packing, tuple unpacking, parallel assignment. 4 kinds of assignments is complete. There's another one which I should talk about is assignment chain loading. I could do this. I could say A is equal to B is equal to C is equal to 10. This is called as assignment chain loading. What does this do? Well, this basically does this. 10 is an object. 10 is represented as an object, as an integer. It's allocated. Then there are 3 identifiers, A, B, and C, all referring to 10. So A, B, C, all of these 3 variables are going to refer to the same object 10. If I can even verify that, let me, instead of using 10, let me use some number like say 10,000. You might now wonder, why am I using a big number? Why I'm not using 10? I want you to find out. I'm going to leave that as suspense for a while. Okay. So you just try to use print ID of A, ID of B, and ID of C. It's all the same. What did I talk about ID? What does ID function do? It returns the unique identity of an object. That is the official definition in Python. From the implementation standpoint, the official Python, that is CPython, the ID function just returns the memory address where the object is allocated. That is CPython implementation. I use the word CPython because the Python language runtime was and is I would say rather, has been written in C completely, all over. It's a C program. The Python executable is technically a compiled C program. Okay. So now you might think, wow, so C is better language. Using C, you created Python. Yeah, just like using steel, you created hammer. Yeah, steel is better. That's good. But hammer is even better because you created a hammer from a steel, so it becomes more usable. So think of Python as a practical layer on top of C. I could put it that way. So if you were a C programmer, you'll be creating all these tools like hammers and screwdrivers and spanners and all these tools. As a Pythonista, you're going to use those tools to build something. You see where I'm getting at, right? So imagine if you're a C programmer, if I ask you to build a building, but all I give you is the sheet of steel and sheet of steel, or just maybe raw, the iron ore. And that's what you start with. You build starting from scratch. That's what you're forced to do as a C programmer, mostly. Yeah, some people might argue, yeah, somebody's created a third-party library, I can just use that. The problem with third-party libraries is that there are no standardization in them. The standard C library is, I would fall short of calling it crippled. To a large extent, it is because it's very, very minimalistic. You cannot really do something practical with it other than using it to build your own tools. And those tools would be used to build some applications. Python, think about it as the tools built. A language runtime is created using it. So you can use more higher level syntax and grammar and simplicity to build your application. That's how you relate Python with C. I'm not going to say that C is bad and Python is good. No, C is meant for a different use case. You want to build an operating system? Today I think C is the best language, preferably by all OS enthusiasts, most of them at least. Yeah, some people might even use C++. And now recently, I think Rust is making its way into the Linux kernel. But that's all. I had to wait and watch and see what's going to happen. But C is still undoubtedly the language of choice by many veterans. You don't want to use Python for that. You want to build a web API? You want to consume a web API? No, don't want to do it in C. The time to finish your project will you don't have the uh, the market will move on. I would say the market will just move on by the time you finish your project, right? So you want to be using a language that just gets up to speed so that it saves your time, and Python is good at that. You want to quickly query a huge data set to fetch some relevant data, do some scraping on it. I think these are the kinds of use cases where Python really shines because all the dirty work is already being done. Sorting, managing data structures, and complex algorithms are all pre-built, available as libraries. Most of them in standard libraries, and you just have to use it to unique. Okay, I digress. Sorry. So coming back to the assignment chain loading. So I was telling you about ID function. I told you about ID of A, ID of B, and ID of C. They all show up the same number. What does that mean? They all refer to the same object because all these numbers are nothing but memory address of one single object. That's 10,000 in this case. And all these variables are referring to the object because they all represent the same ID. That's what it is, right? This assignment chain loading. And some of you might think that the execution is like you are assigning first 10,000 to C, then from C it's going to B, from B it's going to A. No, that's not how it works. In this kind of an assignment statement, this is a right-hand side expression. This alone is a right-hand side expression. Everything before this last assignment sign that you see here, assignment symbol, sorry. Everything before this is left-hand side. This is LHS. Left-hand side is like three variables, I, you, and this person, all three members. Let's join up together. But let's wait for that expression. The expression comes up, all of them refer to them at one go. That's a very simple analogy of visualizing things. So this together is left-hand side, and this is right-hand side. You'll see why I'm emphasizing this in a while. Okay. So let's talk about the next kind of assignment to talk about is augmented assignment. People who have been using C or C++ might have, or many other mainstream languages, of course, might be aware of this. So it's called as augmented assignment. I was not aware of this term until I actually learned Python. I was using it in C, C++, and Java even. And it's only when I started reading Python tutorial, I said, augmented assignment. Oh, what do you mean by augmented assignment? And then I started, okay. We've been using this. And what is that? I say A is equal to 10. I say A plus equal to 5. Print A. What is it? 15. Now you might ask me what's going on here. I put a plus equal to here. For those of you absolute newbies, beginners, I'll tell you what's going on. This plus equal to in this case, is just a shorthand to say the new value of A is equal to the old value of A plus 5. That's why it's called as augmented assignment. An arithmetic operator or any binary operator can be augmented, can be added with an assignment, right? That's how it is. So you could see that when I say A plus is equal to 5, it's just merely a shorthand of telling A equals A plus 5. What does it do? This A is always the right-hand side expression is evaluated first. Remember this. Right-hand side expression is evaluated first. So before assigning to A, first the right-hand side is what? A is referring to 10. Then there's an object representing 5. Using 10 plus 5, it creates an object that represents 15. And now that 15 is reassigned to A. What does it mean? A now points to 15. Came a point. So this is exactly what happens. So if you want me to show it more in a pictorial manner, it's a tool which I was using. Yep, I got it. Yep. So I say A plus is equal to 5. Initially I said A is equal to 10. That means there's an object that represents 10. And there is a variable called A that sort of refers to it. This time I'm going to use very simple things where I can just go put an arrow mark to point directly here. What this means is corresponding to A, there's a value in a dictionary. I think I covered that long time back. Dictionary which has the memory address of 10 and A is a key for that, right? And that's how it is. So this means that technically A is sort of acting like a reference to 10. And when I said A plus is equal to 5, what happened? A referred to 10. And there's another object that represents 5, but there's no identifier for it. Just that 5 is used as a value. So A plus 5, A is 10. 10 plus 5 creates another object called 15. And then you can see that because it's getting reassigned to A, the address which corresponds to A in the dictionary is changed to the address of 15, which makes A no longer refer to 10, like you see here. It now refers to 15. Now, obviously, the question that most of you might have is that, what happens to 10? Is there in memory, right? What happens to it? Well, in theory, it must get garbage collected. What is garbage collection? I'm introducing a new term here. For those of you who are beginners, and many of you come from other languages might now say, I know garbage collection. Yes, right. I'll tell you what that means. Just like in real world, objects which have no references, object with no references are candidates for garbage collection. What it means is they will eventually be freed from memory. I'm wording all these things carefully. I didn't say freed, but I said eventually freed from memory. How quickly or when depends on the language implementation. Python, I think the default Python implementation as I see it today, CPython as of now, uses a reference counting technique. Some people argue that it's not a garbage collector, but you can still call that as a garbage collection algorithm. Reference counting. Every object has references, right? A variable or a name that refers to it. Every object has a number of reference to them. That's called reference count. So if all I have A was referring to 10, the reference count of 10 is 1. And later on, when A now refers to 15, 10 lost the reference. Whenever an object loses the reference count is decremented. So there's nobody referring to 10 this time. From 1, it becomes 0. Sometimes very likely that when I say A is equal to B is equal to C is equal to 10,000, the 10,000, number 10,000 had 3 references. So the reference count is 3. If I make one of those variables point to some other, refer to some other object, it's like I took the label off from one object and stuck it on another object. Obviously, this object has one less label, so one less reference. If you keep doing that all over for every single references to that object, eventually the object will have no more references. And such an object becomes a candidate for garbage collection. It's like this. I remember an interesting uh, experience, I would say, rather. I've been to a hotel in a restaurant. I think if you come down to India, be sure to visit Bangalore. I'm sure. If you are in the IT, that's the place that you want to be in. Bengaluru. I was born and brought up there, and a long time I settled in Chennai, which is my native town, my parents' native town. And that's where I'm living since 2003, 20 years now. But then every now and then I go to Bangalore to get the feel of my birth town where I was born. But anyways, um, well, after a long gap, I went to Bangalore, and I sometimes call Bangalore because I'm an old timer. It's called Bengaluru now. So I've been there, and there's a place in Bengaluru which is Jayanagar, I think, and there's a fantastic restaurant, of my favorite restaurant called Ganesh Darshan. I'm not even sure if it's there today, but it's been more than a decade since I've been there. But last time I was there, I think sometime in 2008, I believe. I think 2007, I guess. There's so much of crowd. I mean, the restaurant had been the most hot restaurant at a point, and a lot of people were crowding around the restaurant. There's hardly any place. And it's a kind of restaurant where you don't really sit and eat. It's a stand and eat restaurant. We call them darshinis in Bangalore, and I've been there, and we had all these small standing tables where people just go place an order, get some nice dosa, and we have different kinds of dosas there. I think they had 57 varieties of dosa, by the way, and I just ordered dosa there and some special varieties of dosa. And you go to the counter, get the dosa, find a place, eat, and you go. Now, here's what the problem is: most people are waiting for their turn for the table to keep the plate and eat, right? So I managed to somehow scrape in there over the weekend and order a dosa, got it. I had my plate. I was munching a few dosa, and I looked around, and then I saw the plate vanished. Wow. The plate vanished, and I'm not done. I'm not done. I didn't finish eating it, and the plate vanished. And I was wondering what really is going on. And then I realized that there are these small kids. I mean, not really kids, but young people, I would say rather. They must be like 19-year-olds, right? And they are aggressively looking at all the tables, all the tables. If anyone on a table just got a plate lying around and nobody's having their hand on it, that's it. Garbage collected. That's called reference count garbage collection. This object lost a reference, immediately freed. And that's exactly how Python works, by the way. The moment an object loses a reference, it's cleaned up immediately. I have another example of garbage collection, which has got to do with another restaurant I'd been long time ago. That restaurant is shut down. It's running on loss. It's a cafe, right? It's the during the culture of cafe coffee day in Bengaluru, there were a lot of similar spin-off that came up, and one of them I remember, just a very nice one though, is called Java City. People who are old timers in Bangalore can recollect this. I remember the Java City in a place called Lavely Road in Bangalore, right? And that's a sprawling place. It's a very big restaurant where you can sit and eat, and it's like extremely understaffed. There's just one person, or sometimes two. Mostly you'll see one person there. The person stands at the counter. I walk in. Any customer walks in, and the person just greets and just points away so that he can pick up the free table around and sit on the table. Then the person comes and shows you a menu, and he goes back to the counter, and later on he comes back and says, what do you ordered? And he'll get you coffee or tea or some snacks. It's like Starbucks, but a very, heavily I would say economical, or rather I will say stripped down version of Starbucks. Okay, it's Java City. It's very popular. It used to be popular in the late 90s and 2000 era, and I remember being there. It's like this, people just walk in, they find a table that's not really dirty or soiled, and they go sit there. They order something, they eat, and they go out. The table is left as it is. All that stale plates are there as they are. Another customer walks in, he finds another table which is clean, goes there, order something, eats, and the table is stale. And there are like maybe about some 20 tables like that, 20 to more than that, I guess. So I think I could roughly think of 20 tables around. So each table, one by one, they get soiled. So when now a new customer comes in, or some few customers come in, and they don't see any clean tables around. All tables are sort of soiled. And now this person who's there at the counter looks around. Oh, he says, "Oh, there's no table available." 1 minute, sir. He just says that, and he goes and sweeps all the table off one go, and then he allows these people to occupy them again. This is how most mark and sweep garbage collectors function. In reality, a language like Java uses a kind of a mark and sweep garbage collector. A lot of improvisations here and there. They use parallel GC, generational, blah, 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 blah. But it's mark and sweep. It's just the optimization of mark and sweep is that you won't wait for the last table to get stale and then, take a long time cleaning up, like say 20 tables. You'll every time keep monitoring and then say, oh, okay, 6 tables are gone dirty. No customers are there. Okay, fine. Let me go and clean up the table. That's the optimization, right? You don't do it immediately. You just let that table, that stale, be marked, allowing customers to take up new table. And this is how memory is being managed by a mark and sweep garbage collector. So whenever you have a new object created and the object loses all the reference, it's not cleaned up immediately. It's just marked. It just marked. It just says, okay, I'll look at you later. And then after some threshold of time or memory usage or various other trigger thresholds, I would say, depending on the language implementation, the garbage collector is woken up. Maybe it runs on a separate thread and then does a cleaning up of all the marked objects to free up the memory. So the memory usage, if you look at it in a graph, they look like a sawtooth. They slowly start using up heap memory, and there's a drop. Slowly start increasing memory. There's a drop. Slowly they increase memory. There's a drop. It looks like a sawtooth, which means that that's a signature of a mark and sweep garbage collector in action. The standard Python, C Python, does not do mark and sweep. Mark and sweep garbage collectors are more sophisticated. They require more sophisticated memory management, and they are generally multi-threaded. So they need some dedicated garbage collector thread which has to constantly keep looking at objects and cleaning it up. Python is like the Darshini Hotel, Ganesh Darshan of Bangalore, which I remember. I'm not sure how it is today, but I'm talking about what it used to be back in 2008, 2009, or around that time frame. 2008, I guess. 7 or 8, I think. Maybe. Long time ago, being there. So it used to be like that. You'll find some restaurants like that, which are like extremely crammed and crowded, and people are always struggling to get place in that restaurant, cram in there, right? And you'll have these people who are there, the staff who's working there. They always are trying to clean up the table so that new customers can come in. So they want the existing customers to be pushed out as quickly as possible so they can get them new customers. Right? That's exactly how it works. Yeah, a long digression. But just tell you all this concept about how objects are managed in Python is no different than how it is done in real world, right? So anyways, coming back here, there's a garbage collector in Python, which is reference count garbage collector, and any objects whose reference count becomes 0, that means there are no references, these objects are freed from memory. They're completely freed up from memory. In this case, I would say that 10 and 5 should ideally be freed, right? But you'll see in reality, there are a lot of these interesting optimizations that are there in Python where 10 is never going to be freed. If the number was like, say, 1,000 or 10,000, yes, it will be freed, but a number like 10 and 15 and 20 will not be freed. There's something very interesting that Python has. I'll talk about that in another day, another session, right? For now, it suffices to tell you that this is how references to objects work. Now, having said this, let's come back to the assignments here. So how many assignments I talked about? I talked about a simple assignment, tuple packing, tuple unpacking. I talked about parallel assignment, augmented assignment, and yeah, five of them, right? But now here's the thing. I talk about assignment. Oh, I talked about assignment chain loading. That's sixth one. I wondered where I missed this sixth one. Yeah, assignment chain loading followed by augmented assignment, right? Six of them complete. There's another one, which is, I guess, the last one, which was a bit of a controversy when it was introduced in Python 3.9, I guess, or was it 3.8? I need to check. 3.8 or 3.9, they introduced this feature, which is called as the Walrus assignment. And this was a little bit controversial to a point where I guess it's led to the creator of Python, Guido van Rossum, uh, resigning from his post of being the benevolent dictator for life for Python. So he used to be called as he's called as the BDFL, the benevolent dictator for life, which means he's the one who's the final signing authority on features that go onto the Python language. Though there's a Python Software Foundation, which has a council or a committee of people who work on standardization and taking in features in Python. Python is now a community effort, but still had a dictatorship role that Guido van Rossum was playing as a founder. He had to step down from the role and become another core developer and a normal committee member, completely now decentralized. No centralization whatsoever. And that's what it is now. Python is, right? So it all happened because of some kind of I would say, a rather heated debate or exchanges that happened in the mailing list of Python or the forums of Python with the usage or approval of this particular feature. I guess in Python 3.8 or I think it's 3.8. I think it's 3.8, right? Which is the Walrus assignment. Before I talk about Walrus assignment, I should tell you what is this all about. I should tell you one important rule in Python, which I want to make a note here. I want to make a markdown. In Python, statements are not expressions. Be very clear of this. Statements and expressions are treated very differently in Python language grammar. You can never treat a statement as an expression, or you cannot have a statement as a part of an expression. What do I mean by that? Okay, let me explain you that. Let's try this. Say A is equal to 10, B is equal to 11. I could have said A comma B is equal to 10 comma 11, but it's okay, right? Not really Python. This code itself is not going to work. That's the whole point I'm going to make. If I try to say B plus equal to A plus equal to 1, what do you think is the answer? Oh, you can see that VS Code is highlighted that. Highlighted the red there, which means it's not working. It's not going to work. Try it out. Error. What's wrong with this? You might wonder. There's a lot of ambiguity in the syntax. I'll tell you why. It's now very difficult to conclude whether this operation happens first or should this operation happen first. You can't be conclusive about it, right? So you can't say, but this has a precedence or this has a precedence. Some of you might say, no, you should first do it from right to left. You should first increment the value of A by 1, and then whatever the outcome is, increment the value of B by that outcome. Or some of you might say, no, it should happen from left to right. Because you're assigning to B first, right? You say B plus equal to A, first this must happen and then this. Python has a rule here. In the face of ambiguity, refuse the temptation to guess. Oh, I just quoted the Zen of Python, by the way. I will talk about that when I have time in a while, but just note that I'll talk about Zen of Python maybe in the next session. It's an interesting Easter egg that's found in the Python runtime, and there's a lot of interesting quotes. But what I'm trying to say is that if there's a ambiguous syntax, the syntax looks a little ambiguous to the Python runtime, it's not going to make any guesswork for us. And we are not supposed to guess anything on that. If it looks ambiguous to me, if it looks ambiguous to me, it will look ambiguous to Python. So Python will just raise an error. Just be sure of that. And this way, your code is more, I would say predictable. What you read is what exactly it does. No ambiguity whatsoever. There's also a reason why Python lacks the plus plus operator and the minus minus operator. If you come from the world of C or C++ or Java or JavaScript or Perl or almost every language I've come across, a lot of languages have this unary increment and decrement operator. What is that? I'm not writing a C programmer. I'm just trying to show you what it means. It's like in language like C, you could actually do this. You could say maybe int I is equal to, assuming the part of a C code, so int I and I is equal to 10 or something, and you can say I plus plus like this. This works. This is a C program. In a C program, you have this unary increment plus plus or unary decrement minus minus. It's a unary operator. It's not binary. It does not take two operand. It just increments the value of that operand. Now, using it as a statement is fine, but the moment you use it as a part of an expression, all hell breaks loose in terms of understanding what this code does. Just watch me when I do this. I say int j is equal to I plus plus, or any C guru will tell you, oh, it's pretty obvious. You just have to increment the value of I first. So I becomes 11. Then you assign it to j. Oh, is that it? No, sorry. First you assign it to j. This means you have to first assign the value of I to j. So j is 10. J is the old value of I, and then I is incremented 11. Oh, this is because it's a post increment. And then you have something called pre-increment. Wait, why am I teaching you C programming here? The reason is this. This might look very obvious, but I remember when I was delivering training at an organization back in 2007, a clever participant asked me this question. Participant. Maybe he was trying to check how good I am in my coding skills as a trainer. We get that all the time when you're into corporate training most of the times. But he asked this question, and okay, it was a very genuine question though. It was not like he was testing me, but he said he got this question in an interview in another company, and the interviewer asked him this question. He said, int I is equal to 10, int j is equal to 11, and somewhere down the line, the interviewer said, the statement was something like this: j plus is equal to j plus 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 I, and now tell me what's the value of I and what's the value of j. Wow. And I looked at that kind of a code, and I just stared back at him blank and said, I don't know the answer. And I also told him, if you had known the answer to this question, and if I were the interviewer, I will not hire you. And the participant just stumbled. He's like, why? I said, no, if you put code like this in production, you're going to waste everyone's time. You're going to waste everyone's time, because somebody's looking at this code. What is he going to see? He's going to say, j plus is equal to j plus plus plus. Okay, let's open up the editor. Let's try it out. You just wasted his time. You never want to write code like this, which hurts somebody's brain. No, sorry, this is not the right code. There's nothing accomplished with this. Oh, you're going to save maybe a few CPU cycles with instructions. I think the programmer's time any day is more expensive than CPU time, always. That's why today we live in an era of automation, replacing humans with machines for doing all the work. Human time is very expensive. Machine time is cheaper, is getting cheaper every year. So don't bother about saving 1 or 2 cycles of CPU cycles in this, right? I don't think this gives you any optimization benefit, I believe, right? It hurts readability, and don't do this. So this is possible in C, I realized. You can't do this in Python. Reason? Python does not have a unary operator. The actual reason is their technical reason is the language grammar doesn't support it. And the side effect benefit is that these operators are overly confusing, and it's better not had. So if you really want to increment the value of a variable by 1, you say a plus equal to 1 or I plus equal to 1. And yes, that's a statement. You can't use it as a part of an expression. Remember what I told you? All of these today's topics were all about statements, not expressions. Assignments are statements. Assignments so far are statements. So none of these assignments can be used as a part of an expression. You can't do that. So which means that when you're trying to say b plus is equal to a plus is equal to 1, like I tried in the other cell here, what I'm effectively trying to do is that I'm trying to treat this as an expression, which is not supported in Python. It's a syntax error. It's not a runtime error, it's a syntax error, which means that your program will just fail to start off, right? If this code existed in the last line of a 1,000 line code, not a single line will be executed. I keep telling you that, right? When I talk about syntax error. So note this. So this is not supported in Python. Okay. If somebody asks you this question, b plus is equal to a plus is equal to 1, don't struggle to find out the answer. No, the answer is syntax error. Blind. You know that. If it looks ambiguous to you, you can be very sure that it's ambiguous to the Python runtime also, and it's going to fail with some kind of an error. That much you can be confident about, right? And yes, there are no unary operators in Python like the plus plus and minus minus, right? Because of their ambiguous nature when used in expressions. In Python, anything that looks very ambiguous is better not even have them. They discard them off and they keep them clean, keep the language space more clean that way, right? Walrus assignment, which got introduced quite recently, sometime in 2018. Was it 2018 or 2019? Around the time frame. I'm sure it's before the COVID lockdown. It was 2018, I guess. I think it's 3.8 if I'm not wrong, not 3.9. I was thinking it's 3.9. I think it's sort of recollect as 3.8 version. This was controversial and it came after so much of pressure. The problem with Python not able to treat statement as expression had a weird limitation. The limitation was pretty much evident when sometimes you might want to evaluate an expression and assign it to a variable and then check whether the variable's value is meeting some condition. Suppose we used in while loops and if conditions. If you ever did read a book, The C Programming Language by Brian Kenigan and Dennis Ritchie, the book for C programming, the Bible for C programming, right? I think it's in second chapter, if I'm not wrong. What's the second chapter? Just hang in there. I'll just get the book. Just hang in there. All right. Just sort of vanished behind my green screen and I'm back. That is the book I was talking about, the C programming language. I still have it. Oh, there's a sixth book and it's still already. It's the only book that looks very old and tone bit. Sorry about that. It's very old, of course. And I think somewhere in this book, somewhere. Where's that? Where's that? Where's that? The first chapter, the whole chapter talks about print hello world. Okay, let's move on. Let's move on. Let's move on. Character input, blah, 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 word counting and all this stuff. And what was it? Oh, it's in the first chapter itself. Yeah, it's all over the place. It's all over the place. And I think the chapter which I want to show you, thought I could write it off here. So I'm trying to see. It's been a long time since I read this book. I'm opening it up after mostly 2 decades. 2 decades, by the way. But I think I'll show you where that is. I think try and look at the simplest one of it. Yeah, something like this. Not sure if you can see this here. I'm not sure if you can see the book. Never mind. I'll just type it off. I'll show you. What I was trying to show you here is a Dennis code, right? Not the exact one in the book. I'm trying to sort of type it off here. And it's all got to do with this, you know. So int main and maybe you would have int ch and you would just say while ch is equal to get char and not equal to EOF. And you say put char of CH. And yes, now VS Code is totally confused. What am I doing? What am I doing? It's like, oh, well, it's not Python. This is not Python. Right. It's fine. It's not going to be a, I'm not going to execute this. Just trying to show you an example. This is the kind of code you are seeing. A slight variation here and there, okay? But the most important part is this is an assignment. Get char is some kind of function. You call that function, you assign the return of the function to a variable, and then you check the outcome of it and check if it's not EOF end of file, and you do put char. That means you're trying to use an assignment as a part of another expression to be verified by the condition of while loop condition. It's a looping construct. Oh, for those of you who are beginners, don't worry. This is just a kind of code that's reminiscent of C. You're lucky you're learning Python because you don't have to worry about all these nuances of hash include, int main, and int ch, and all these messy braces around. Things are simpler in Python. Oh yeah, semicolons. You don't need that. Yeah, you can see Python is straight to the point, very simple, very practical, right? But now, nevertheless, this kind of feature is not supported in Python for a long time. Now, the Walrus assignment aimed to solve that. So this is an assignment statement which can be used as a part of a condition. And though you can abuse Walrus assignment to create completely ambiguous code, today, the only place where you should use Walrus assignment is in a while loop or an if condition. It is illegal. I would say it's like a criminal offense to use it anywhere else. Now, I may be strong at this, but that's what you should think, right? If you plan to use Walrus assignment anywhere outside the while loop or if condition, note that the person who's going to read your code is waiting with a huge weapon in his hand or her hand and is aiming at you, right? You don't want to do that. So avoid it. So avoid this as all you can, but there are some places where you really need it, which makes your code look succinct like the Denisovich code, which was lacking in Python for some time. So I would only use it if I'm going to use it within a while loop or within if condition, nowhere else. What is the syntax for it? The syntax is very straightforward. It's telling, I'm going to show you the while loop in Python. It might be jumping the gun. I'm not teaching you looping construct, but I'm going to show you something. Traditionally, for all I want to getting user input until the user says returns a specific number. Let's say this code is definitely not Pythonic, okay? Definitely not. Just trying to show you a silly example, silliest as possible. So I say total is equal to 0, and I'm going to do things like, so now I'm just going to say while true. This is not Walrus assignment. Why we need Walrus assignment is the clue here. Clue on why we need Walrus assignment. So it's a while true, and you might ask me what while true is. While forever, that's what it means. True returns 1. While loop will execute statements inside a block until the loop condition becomes false. But this will never go false, so it's forever. Why I need this, I'll tell you. Again, say n is equal to int of input of enter a value or 0 to quit. And then I'm going to say total plus is equal to n. That's it. I'm going to print total equals total. There's a lot to talk about compound statements. It's a topic for another session. Just to keep the explanation simple, all I should tell you is that this is a compound statement. Okay, while true, colon. And after that, whatever goes inside it is a body. And the body in Python must be indented. That's a rule. It's not optional. You have to indent it. That's what I'm going to stress about more when I talk about decisions on compound statement. They all have a pattern. They'll always start with the keyword. They have some specific syntax based on what statements you're using. They end with a colon in the prologue. And after that, they have an indented block of code. And no curly braces. No curly braces. Right? And this is how it is. And for now, what it does is, I'll explain the logic. Total is a variable that's set to 0. while true, while forever, n is equal to int of input of enter a value. What does it mean? It just takes a number from a user. I guess I told you what this int of input does, right? It takes a number from a user, but I want to quit when it's 0. Oh, this does not quit. This goes on forever. Let's provide a logic for quitting it. So I need a condition for that. Yeah. If not n, break. This is how we break out of a loop. I want to break out of the loop. I want to exit out of the loop when n is equal to 0. Where I put not n, I could say n double equal to 0. Okay, let me not go too Pythonic for today, for this session. I say n is equal to 0, break. Let's make it more explicit. So I say if n equals 0, break. Otherwise, total is just accumulated with n. If it comes out of the loop anyways, once I'm done with it, it's going to print the total. I'll run this now. 5, 6, 2, 34, 9. So it's continuously asking me questions. The only way it'll stop is when I say 0. The moment I type 0, it stops, and you can see the total accumulated result out of all the numbers I typed so far. It sort of accumulated them, right? If you want to make this code even more shorter or simpler, you can use Walrus assignment. How you do that is this. In my earlier career, with Python, every time I saw a while loop, I would say out of 7 out of 10 times, 7 times out of 10, it's always a while loop. And there's some other condition checks inside and they break out because there's no do while in Python. That's a big reason, right? So you can't determine the loop condition beforehand before you enter the loop because you want to do something, and then you'll decide whether you want to continue with the loop or not. So you'll start with while true and you do it like this. But the moment you use Walrus assignment, things can be simplified. You could normally, instead of using while true like this, which looks pretty meaningless in general, I can say while open parenthesis. Here's where parenthesis is important. You say while open parenthesis n colon equal to. Walrus assignment is colon equal to in Python. You can see a colon equals being used here. So this is very important. The symbol is this. And then equals. Let's quit blah, blah, blah. Okay, I think I need to close this. I think that's sufficient. Yep. I reduced any condition. You don't need that. And this still works exactly similar. Let me try 10, 20, 30, 40, 50, 0. What's the answer? 150. So here, you're evaluating an expression and then you're assigning the result of the expression to this variable and then checking whether the outcome of it is something. In this case, while loop, I'm not even checking the outcome because if the outcome is true, evaluated as true, it's going to continue in the loop. Otherwise, it's going to break out of the loop. The point is, the Walrus assignment is used specifically in case of while loop or if condition, where you want to evaluate an expression, assign the outcome of the expression to a variable, and then check if the variable matches something based on some condition and work accordingly. That's the only use case for it. And this is the recent introduction. I think it's pretty much from Python 3.8. I should double confirm that. I will show you how to find out which version of Python had it. The best way to check that is obviously the documentation, right? So we'll just open up the documentation. Where's that? Okay, the browser. Yeah, okay. So you just open up the python.org documentation and where do you get all these things? Okay, let's go to docs and yeah, go to Python docs. I don't think this is covered in the tutorial, is it? I don't think so. I don't know if there's assignment specifically covered in tutorial. It might be buried somewhere deep down, but you can spot it. But you will definitely find all the syntax grammar features in another document. See, tutorial, library reference, everything to do with the Python syntax grammar is under language reference. It's pretty detailed. And it talks about all the things about how the syntax grammar works. And somewhere down, you'll find assignments, assignment expressions. Sometimes named expressions or Walrus assigns an expression to so and so. It is introduced in Python 3.8. This Walrus assignment is now officially called as assignment expressions, right? So you might wonder why it is called Walrus assignment is because of the smiley. So it looks like a smiley. This is no different than uh, we lived in the era when we use smileys. Today we use emojis, stuff like that, right? All these iconic stuff to put smile and all the things that you do in messaging and chat. But then there was a time when systems were not graphical and people use smiley like this to say I'm smiling, or I'm grumpy, or I'm sad. Like this. I'm sad, or I'm just a little. This also is like sad, I guess, maybe. Or you could also say like this. This called as a Walrus smiley. This one, right? It's not like how I'm smiling, by the way. Right. Anyways, so you can see that colon equal to is like part of the Walrus smiley. You just open colon equal to and end with a parenthesis at the end. Obviously, it also means that you should start with a parenthesis for that. So that's where it gets that name from. Anyway, so this completes all the kinds of assignments that you should be aware of in Python, right? I talked about all the different kinds of assignments. I should make a note that this is a C program, don't run it. And put a smiley there. Okay. Anyway, so this is a dummy C program. But I've just covered all the different assignments. So just to summarize, I think there are totally 7 kinds of assignments in Python. So we have a simple assignment, we have tuple packing, tuple unpacking, parallel assignment, chain loading, assignment chain loading, augmented assignment, and then we have the Walrus assignment. That makes up the 7 ways that you can use assignments in Python. And all of these assignments do one thing. They create a new variable as a new identifier. That is obviously if they don't exist. If those variables already exist, they reassign them to a new object based on the right hand side's outcome. I can say a is equal to 10. This is one of the things you should know. The last feature I talk about is I keep telling that Python is strongly typed, but the types are not associated with variables. Right? I talked about that, which means you could say a is equal to 10. What is a? It's an integer. The very next statement, you could try to say a is equal to hello. What is a now? It's a string. And then you can say a is equal to, and you can type a is equal to maybe a list. And what is a now? It's pretty obvious that I was able to reuse the same variable to first point to one object that's a number. Think of it like a sticker, a label, sticker label stuck on an object. I took that label off, stuck it up on another object which is of different type altogether, which is now a string. Then I can take that off, take the sticker off from that object and stick it on another object which is a list. So types are not associated by default with variables in Python grammar, right? It's a feature of an object. A number is an object. A string is an object, and a list is an object. Variables have no types. It's the objects that are strongly typed, right? So this is how dynamic Python is, and this is a very debatable concept. Sometimes people say, "Oh, this is not type safe" and all that. We'll discuss about that in the further sessions. For now, these are the things you should know. The last before I wind up, I know I already spilled beyond 1 hour, but this is important. I don't want to skip this. The last thing I should tell you is a common mistake that people make as newbies, sometimes even expert Pythonistas. I will not show this on Jupyter Notebook because it gets a little messy. So I'm going to save this notebook at this moment. I will show it to you on the Python prompt, but this can get totally messy when you do that in a Jupyter notebook interface. Don't try it. Just watch me. Maybe you can try it and then restart your notebook, of course, right? I'm going to launch the Python prompt here and the shell or the Anaconda prompt if you want to try this on Windows. We have learned a lot of built-in functions, haven't we? Yeah. Let's take one of this function, which is a hex. What does hex do? Hex prints an hexadecimal equivalent of a number like this. Nice. Hex of 10 is 0xa. Now, sometimes I will do this. Hex is equal to, yeah, this is doable. I said x is equal to, it's an assignment, right? I assigned 0x3ac to hex. And then when I type hex of 10, I'm trying to call hex function, by the way, you get this error. Wow. Worse, you know what somebody does. Str is equal to hello world. Oh, sorry, forget parenthesis, ignore that. It's a mistake, syntax error. Str is equal to hello world. And then you forgot about it altogether. Maybe you even clear the screen, and then sometime later you just have a number. You have, say, a is equal to 5.6. It's a floating point, and you want to print this as a string. You want to convert it to a string. You say str of a. This used to work before. What happened? Yeah, I'll tell you what really happened. Whenever you encounter this error, type error, some object, str, int, list, whatever, object is not callable. If you get this error, what this really means is that you have reassigned a built-in identifier, which was essentially a function, to something else of your own, right? So because you created an identifier called str of your own, this str that you created is now pointing to a string object. It's no longer pointing to the string type. It's no longer string type. The hex that I created, hex is equal to something, is now representing a string object, is no longer referring to the built-in hex function. And there you have it. And this is a problem. So you have a lot of these built-in functions like print. Oh, I found this. Many people did this. So somebody said input is equal to 56. Wow. Input is equal to 56 and forgot about it. And then sometime later, the person tried input of enter a number and then start complaining, why is Python so inconsistent? No, Python is very consistent. It's just that you're not aware of that. In Python, everything is an identifier. Everything, right? When talking about function name is an identifier. So all identifiers are assignable other than true, false, and none. Apart from these three built-in reserved keyword identifiers I talked about in the earlier sessions, every single identifier is reassignable. That's what you should know in Python. You can reassign to any built-in function. Now you might think, oh my God, this will all hell breaks loose. What if somebody does this? Somebody says print is equal to 10. Oh, I can do that. Print is equal to 10. And you know what? The rest of the program, print, will no longer work. Isn't that dangerous? Is that bad? Well, it's not. Python assumes as a programmer, you know what you're doing. The language never aims to come in your way. When it comes to your logical decision making, the language is completely free form. It doesn't come in your way, right? So you should be cautious enough about this. So if you said print is equal to 10, that's your problem. Why did you create a variable by name print? Or maybe because you forgot that print was a built-in function. Oh, now on you will remember. Right? So that's what you should know. Anyways, there's a reason why this is also available, but that's a topic for another session. Sorry, I keep telling another session for whenever I go on further, but I'm going to create layers, right? So yeah, you'll start seeing the reason why this feature exists in a good way later on. You can do wonderful things knowing this feature. Wonderful things, right? which is not possible in many other mainstream languages even today. A lot of these popular languages, C++, Java, C, you can't do this. You can't do something like this. You can't just take a function name and assign it to use it like a variable. You can't do that. But that actually also means there are some limitations in some concepts, some of the features that you can achieve, right? That can be done much easily in Python, which I'll discuss much later. Keyword, monkey patching. That's the main catchword here, right? I'll talk about that when I talk about monkey patching. You'll see how you can monkey patch just about anything in Python, right? Which is the most interesting way to express object orientation. All right, I think I spilled over. Sorry, 1 hour 25 minutes this time. So, but anyways, I want to cover assignments. I digressed a bit here and there, but I covered a lot of other things. Came back to the fold. But I guess this should be the all video that you should know about assignments in Python, right? Hope you found this video useful. If you stayed along so long, thank you very much. I will continue with next set of statements, mostly very quickly. I will, in another 2 or 3 sessions, I will talk about compound statements, and you will have most of the core ingredients of Python ready. So we will actually create more interesting projects and programs as we learn further and when we dig into data types in Python, right? Thank you very much. So as usual, if you really like what I'm doing, if you really like this video, do hit the like button and please share, subscribe. And if you have any queries or doubts or any questions, feel free to post them on comments. Thank you very much. So meet you in the next video.